avoid the load in the single chain. We have some assumptions for our proposed network build, like base station is located in center, and we take the 100 nodes which are homogeneous. Their initial energy is the same for everyone, 0.5 joule. And after that, the energy cost for transmission and reception is same. In some application, delay of the data will be not tolerated. So in that case, our proposed protocol is good. For the network model, we have some defined the following parameters: network area 100 meter into 100 in x and y directions. Total number of nodes is 100, and the length of the data transmitted 2000 feet. And electronic part and receiver part has the same energy for 15 nanojoule, and the extra additional energy in the transmission part, that is the amplifier part. It contains 10 picojoule. The initial energy of every node is 0.5 joule. Data aggregations or data fusions is a 5 nanojoule, and the factor at which rate we aggregate the data is 0.6. That is our node deployment in the field. We take 100 nodes and we divide the complete field into 4 equal sections area wise, and they contain like 25 nodes. 25, 25, 4 have the 25 nodes, and after that we make every 25 node is a chain, and they transmit their information to the sink that is located at the center. In because if they have only single chains, they we contain in the same node 100 nodes 4 chains. There is a radio node. The fixed amount of energy spent for the receiving and transmitting part, that is electronic part, which is common for receiver and transmitting part. Only additional part in the transmitting is that is the amplifying part. We need to amplify the information. If we see the distance factor, the signal may be weak, so we can use the amplification extra part. After that, chain construction. Greedy algorithm is used for the constructing a chains that starting from the farthest node, and after that each node is connected with the nearby nodes, and they send their informations next node compress that information and data fuse and transmit it to the next node within the same length. So how we select the head node based upon their threshold energy. That is, we take a P as a desired percentage of probability of head node, and R is the current node. The R is randomly choose between 0 to 1. If that value is less than the threshold voltage, then it should be chosen for the head node. In every round, there is a different head node chosen for the balanced distribution of energy in the field. There is a 4 chain we have put in this field. Every field have their own chains, and they differently transmit the data to places. Instead of using a long single chain, we can use a short core chain that used to avoid the delay in the prediction. That is the result and simulations. Comparison of aligned nodes. In a simple figure, if we say that at near about 100 round, up to 100, there is a 100 node will alive and condition. After 800 round, they start dying. But in CS Pegasus, up to 1300 round, all nodes are alive. So we can comparison to dead nodes and similarity conclusions.
What happens if the network size is more?
The network size is same in both cases.
Let me increase the size of the network. Let's increase the size of the network. So, what is the effect on the performance of this device?
If we decrease, but the nodes are in the same condition, if it is divided on we take the 100 node, 100 node, performance according to that is very important.
So that's why this protocol is good for the network size large or the network size is small.
If we also give the density in that particular area, we are just assuming 100 into the network. It may be large or small.
Because this is known for a small network, not good for a large network. This is the disadvantage. This is a chaining process.
Yes.
And if there is, you are going to do the chaining, definitely that is why you are divided into four chaining process. Instead of two chains, you have divided into two chains, or four chains, right? So that is why performance is improved. So that means this kind of a protocol is good for a smaller network, not for a large network.
Our CSP classes have the good improvement over the large network over the Pegasus. Here,
That is why because is not good.
Pegasus is not good for large network.
And what are the other? Can you define any application where the because
Pegasus is used.
any application?
Since your canvas very more long medium and larger section network.
Anyone from the audience? Thank you.
Thank you.
Next paper after presentation is paper code 112, Dinesh Sharma.
A very good afternoon to all. My name is Dinesh Sharma. I am student of BTech Electronics and Communication. I am here to give a presentation on the evolution of Wi-Fi technology wireless networks. Firstly, we are going to cover the evolution of wireless technology. The comparison of Wi-Fi with Bluetooth and Wi-Fi will be discussed. The features of Wi-Fi and application and features covered is discussed in this presentation. Coming to the evolution of wireless technology, we were using the cables for communication in earlier times. The cost of cables are very high and it is making the system very complex. So there was a need for more simpler systems to communicate. So there was introduction of infrared and cordless systems, that was wireless access systems, by which we can communicate between two devices without any wires. It is making the system more less complex and more simpler. But the problem was that they only work in a line of sight networks. So another technology was developed at that time in 2024, that was Bluetooth. The Bluetooth completely changed the scenario of communication. It replaced all the wires. I can say it kills the wires from the systems. We can communicate with the two devices in the range of 10 meters by using Bluetooth. The data transmission rate was very good at that time. There was limited size of data, that's why it is very good. But as the time goes, the size of data increase, we need a technology which could serve the better area. So Wi-Fi was introduced, which was having the range of nearly 50 meters and having data rate of nearly 11 Mbps. But later on, we need to cover a more area. So Wi-Fi was introduced, that was having the coverage of nearly 65 kilometers with stationary ports. But in nowadays, as size of data is increasing, we need to transfer very large files from one point to another. The WiMAX is not that successful for that, so the introduction of Gigabit comes here. That was the first transceiver chip that was developed by the students of Melbourne University, Australia. That is having a size of nearly 5 by 5 mm and working on a frequency of 60 gigahertz. It can transmit the data at a rate of 5 Gbps, rate is nearly 10 times that currently any system can do. So why there is a need of Wi-Fi? That we can transmit the data like videos and audios in just a blink of our eyes. The data rate is nearly 10 times the earlier networks. It can be considered as a challenger to Bluetooth and Wi-Fi networks. We can transmit a video file of nearly 3 and 4 hours and having a size of nearly 3 to 4 GB in just a few seconds. Now the comparison of Wi-Fi with the Wi-Fi Bluetooth here. The Bluetooth was developed in 1994 by the Sony Racing company. The specification for Bluetooth was the Bluetooth SIG. The Wi-Fi was developed in 1999 and it was developed by IEEE and the WECA, that is Western Electrical Contractors Association. The Wi-Fi was developed in 2004 and it was developed by NICTA, that is National Information and Communication Technology Authority of Australia. The power consumption of Bluetooth was nearly 5 milliwatt and that is very less for certain devices. We can use it in mobile devices. The Wi-Fi was, which is having a much better range, is consuming more power of 10 milliwatts, while the Wi-Fi is having consuming the power of nearly 2 milliwatt, which is very less as compared to Wi-Fi and Bluetooth. The data rates of Bluetooth was nearly 800 kbps while it was developed, which can serve at that time, but it is not that much successful nowadays. The Wi-Fi was developed, it was having the speed of nearly 11 Mbps and it can be used in a range of nearly 50 meters. But the data chip is having a very much higher rate of data transmission, that is 5 Gbps. The frequency spectrum on which Wi-Fi and Bluetooth was working was 2.4 GHz, but Wi-Fi is working on 57 to 64 GHz of frequency band that was unlicensed band and used for research and industrial purposes, and we can use it for our local functions, like we can create a small networks with this. The range was already told that Bluetooth was having the range of 10 meters, Wi-Fi was having the range of nearly 50 meters, and Wi-Fi was having the range of 10 meters. Coming to the features of Wi-Fi, the chip was fabricated by the students of university, was costing nearly $10 to them. If it is mass produced, it can cost less than $1 to each of us. So you can easily use any of the devices without increasing any cost on that device. The high speed data rates of Wi-Fi can be this another feature. The high security is a very important and crucial feature of Wi-Fi. The main issues that we are facing with Bluetooth and Wi-Fi is security problem. It can be easily hacked. It was using a 32-bit encryption technique, which can be easily hacked by any of the user, but Wi-Fi was using a 64-bit encryption technique, so it is very difficult to hack such networks. It is making the system simpler, so there is no complexity in the system. We can install a application in any of the circuit and directly use it. It is very simple to use. The power consumption of Wi-Fi is nearly 2 milliwatt and it is consuming very less power. So another feature is portability. We can design or we can create a Wi-Fi network at any place, and we can move that system at any place. We are using a frequency view spectrum, like the same frequency using at different places in Wi-Fi networks. Now coming to the applications of Wi-Fi technology, the Wi-Fi can be used in Wi-Fi access devices, that is PDA, Bluetooth devices like mobile phones, smartphones, laptops and PCs. It can be used to broadcast a video, that is like we are using a video transmission inside a stadium, and we can watch the HD video deep inside stadium, outside of the stadium. Like people are sitting outside the stadium and watch HD video at the same time it is happening inside the stadium. The office appliances or the home appliances can be easily communicated by using Wi-Fi technology. The video transfer, we can transfer videos like we are using a mobile phone and a laptop, we can transfer videos at the same speed, and in just a few seconds we can transfer videos from mobile to laptop and laptop to mobile. The security on the board can also be enhanced by using that technology. We can use inter-vehicle communication systems in which different vehicles can communicate using Wi-Fi chips, and better roads can be developed. Coming to the future scope of Wi-Fi technology, we can use it in smartphones. We all are having Android phones and we are still using that core technology of Bluetooth. We can replace it with the Wi-Fi technology. The smart homes and offices communicated by coming to the way that Wi-Fi is very crucial and playing a very important role in the current scenario. We need to research more on that so that we can make a better technology for the future. Any questions or comments?
What is the full form of Wi-Fi?
Gigabit fidelity.
Gigabit fidelity. And why the range is so small?
So it is using a 64 gigahertz, so it can't be slightly more gigahertz.
Well, what is the reason?
So power in the place nearly 2 milliwatt, so you cannot produce that much area.
You see, sir,
We can replace by using point-to-point communication.
power you can enhance. Power you can enhance.
Sir, that's a feature of the packaging that it is consuming very less power, so that we can integrate in certain circuits that having very low power.
So there is another technology Y8. You have heard of that?
Yes.
It will be 11 AC and 11 AD. They are having the same technology they are using.
Sir,
So
this,
now the question is that you are using ultra wideband. So what is our enabling technology for getting this high data of 5 gigabits? What is the technology behind the high data rate you are achieving in this?
sir, it is using time delay duplexing system on a package and multiple input, multiple output.
Okay, that is one thing, but it is a mode of this OFDMA is used or something, SDSDMA is used. So what is the modulation?
So modulation GMS.
But you should have some more elaboration on the comparison of this technology with some competing technology. So this is not the absolute technology we can have. This is mainly covering the personal area network, and moreover, this is covering 60 gigahertz band, which is having a path loss problem. They only cover the line of sight. So that is the main reason server does.
Sir, it is a replacement for Bluetooth devices. Like we can use it in local networks. Like we can transfer data from one mobile to another. That's why.
The other technology is that one is wireless USB. Heard of that? Sony is coming, the other Samsung is coming to that. So which is also transferring 25 gigabits.
We just reviewing the paper. We want that.
You
Why ask me to
just go
learn
to
that?
the comparison of this technology with the other competing ones. Then it will be able to give you can say overview of this technology.
May I call paper code 010 of the presentation, please? Shruti Bajaj. Thank you. Good afternoon, sir. Good afternoon, everyone. My topic of presentation is review of reactive, proactive, and energy efficient protocol in maths. Now, coming to the presentation, first of all, we'll have an overview of what is an ad hoc network, then what are reactive protocols, proactive, and energy efficient. In the end, we will conclude the session with conclusion and future work. What is an ad hoc network? An ad hoc network, it is a local area network built spontaneously as devices connect. The individual network forward packets to and from each other. A mobile ad hoc network that is basically a managed, it is a spontaneously self-configuring infrastructure-less network of mobile devices connected without wires. Routing in managed, it is a critical task while due to highly dynamic environment, that is the topology keeps on changing rapidly. Efficient routing protocols make managed highly reliable. Protocols in managed are of various kinds, such as proactive, reactive, and energy efficient. Apart from these, there are many efficient protocols, but in this paper, we have covered these three protocols. The purpose of this paper is to analyze different protocols used in managed. Now, basically, just a rough overview. What is the routing? Routing is just the process of selecting the best possible paths in the network. It is also used as a means to forward the network traffic among networks without the existing of any centralized control or pre-existing infrastructure. It is a key feature of the internet, and it enables the messages to pass from one computer to another and eventually reach the target machine. Energy. What is basically energy managed? Energy basically is related to the battery, the power lifetime of the network. Energy efficient protocols are classified on the basis of approaches which are used to minimize the energy consumption. The battery power, network lifetime, and bandwidth, they are crucial resources in energy management. First protocol that we are going to discuss is reactive routing protocol. Reactive protocol searches for the route in on-demand manner and sets the link in order to send out and accepts the packet from source to destination. That is, if you have to transfer the packet from one node to another, then only this protocol will work, otherwise it will not work. The first protocol of reactive routing is on-demand based energy efficient routing protocol, that is OTBEERP. It is a source-initiated on-demand routing protocol whose aim is to discover the minimum power limitation. The minimum power limitation of a route is decided by the node which has minimum energy in that node. So compared with the minimum energy in any other route, the minimum node with minimum power route has more energy in this protocol. The next protocol is dynamic source routing, that is DSR. It is simple and efficient routing protocol designed specifically for use in multi-hop wireless network or mobile nodes. It allows the nodes to dynamically discover a source route across multiple networks to any destination in the ad hoc network. Each data packet sent carries in its header the complete ordered list of nodes through which the packet must pass, allowing the packet routing to be loop-free and avoiding the need for up-to-date routing information in the intermediate nodes. With the inclusion of this source route in the header of each data packet, the other nodes which are forwarding or overhearing any of the packets, they may easily cache this routing information for future use. The next protocol is temporarily ordered routing algorithm, that is TORA. It is also highly adapted, efficient and scalable routing algorithm which is based on the concept of link universal and was invented by Vincent Park and M. Scott Forson from University of Maryland. It is proposed for highly dynamic mobile, multi-hop wireless networks and is source-initiated on-demand routing protocol. In this, the control messages are localized to a small set of nodes near the occurrence of topological change. The nodes in this maintain the routing information about each of its adjacent nodes. This protocol has three basic functions, that is route creation, maintenance, and route erasure. The order has a unique feature of maintaining multiple routes to the destination so that the topological changes do not require any reaction at all. In this, when we initiate a query, our node broadcasts a query to all its neighbors, and this query is rebroadcasted through the network until it reaches the destination or an intermediate node that has the route to the destination. The recipient of the query then broadcasts the update packet, which this is sent with respect to the destination. Now coming towards the other protocol, that is proactive protocol. Even if we are not on demand, this protocol will work continuously. In this, each node in the network has a routing table for the broadcast of data packets and wants to establish connection to other nodes in the network. The first protocol is optimized link state routing protocol, that is OLSR. In this protocol, it uses hello messages and topology control messages to discover and then disseminate link information throughout the network. Individual nodes use this topology information to compute next home destination for all the nodes in the network. Hello messages are transmitted to all the neighbors in a single network. Topology control messages are link state signaling done by OLSR. Multiple interface declaration messages are transmitted by nodes running OLSR on more than one interface. These messages list all IP addresses used by the nodes. The next proactive protocol is wireless routing protocol, that is WRP. It is an enhanced version of the distance vector routing protocol. It is used to calculate paths. This protocol introduces mechanisms which reduce route loops and ensure reliable message exchange. To enable fast routing, it employs a unique method of maintaining information regarding the shortest distance to every other node in the network. It maintains an up-to-date view of the network, and every node in this network has a readily available route to every other destination node here. In this, three types of tables are maintained for accurate information such as distance table, routing table, link cost table, and message retransmission list. The last protocol proactive is distance sequence distance vector routing, that is DSCV. It was developed by Charles E. Perkins and Kevin Hagen in 1994, and in this, the packets are transmitted between mobile nodes by using routing tables which are stored at the mobile nodes. Each routing table here contains a list of all the available destinations and the number of hops to each node. Each route table entry is tagged with a sequence number which is originated by the destination nodes. Every mobile node periodically transmits updates and the routing tables are updated. Routing information is advertised by multicasting the packets, which are transmitted periodically as topological changes are detected. Coming to the other protocol, that is energy efficiency protocol. The purpose of this energy efficiency is to minimize the energy consumption and maximize the lifetime of the network. And this is built on two cases, that is energy consumption of nodes and routes and link stability and location stability. The first energy efficient protocol is flow augmentation routing, that is FAR. It assumes a static network and finds optimal routing path across a given source destination pair, which minimizes the sum of link cost. Here the link cost is expressed as 1, 2, 3, xi, xi, eig, capital E and R, where small eig is the energy, capital E is the initial energy, and R is the residual energy. A link requiring less transmission energy is preferred. At the same time, a transmitting node with high residual energy leads to better energy balance is also preferred. And depending upon the parameter x1, x2, and x3, the corresponding routing algorithm achieves a different goals. The next protocol is threshold sensitive energy efficient sensor protocol, that is TEAM. It is targeted at reactive networks and is the first protocol developed for reactive networks. In this, at every cluster change, the cluster head broadcasts to its neighbor its attributes and its hard thresholds. It is the absolute value of the attribute beyond which the node sensing this value must switch on its transmitter and report onto its cluster head. There is a small change in the value of the sense attribute which triggers the node to switch on its transmitter and transmits. The first time a parameter from the attribute reaches its hard threshold, the node switches on its transmitter and sends the sense data. Next, the last protocol is energy efficient, that is multi-path energy aware protocol, MEA DSR protocol. Here, this is just an extension of DSR protocol. Here, the root discovery mechanism of DSR was modified in order to implement a multi-path and energy aware routing. A caching update mechanism through probe backends was included to have always updated information in the routing cache. Round-robin data scheduling among multiple routes was selected in order to balance the traffic load and energy consumption. With the purpose of having all possible paths between source destination, the destination replies to all RRQs that arrive and the source knows all the paths of received RRQs. The paths are measured by energetic metric, which is known as the cost function of the path. It is computed by RREP, process the network from source to destination, and is sorted in the routing table at the source. Spreading the traffic among multiple routes improve balancing, alleviates the congestion, bottlenecks, and prolongs connection lifetime. This protocol wastes less energy as compared with modified DSR and DSR due to round-robin scheduling. Finally, the conclusion. In this paper, we have analyzed and investigated some proactive, reactive, and energy-efficient protocols. These protocols, the different protocols, they behave perform well under different conditions. For example, TEAM is found to be more energy-efficient protocol. TORO behaves well under reactive condition, and WRP behaves well under proactive condition. The future work of managed routing protocol, this can involve the implementation of new routing protocols using these only by investigating these protocols of these limitations and modifying them.
You have summarized various type of protocols
Yes.
related to proactive, reactive. Can you explain which protocol is used for which application?
So like if you have to increase the energy level in any network, then we have to use the TEAM protocol only. And if we are given a network to deliver fast messages from our source to destination, for fast messages we are using WRP.
But you have to define where we need the fast message. The application must be there. So you have to see the applications, which protocol is suited for which application. So that has to be taken care. And how this managed is different than the other wireless.
So in managed we don't have any architecture. This is an ad hoc network. We don't have any infrastructure of managed. The nodes are mobile. The topology is dynamically changing. No, there are no stationary nodes. आप कहीं भी देखिए सारे मोबाइल जो nodes are mobile, they keep on moving continuously from one place to another. So in this manner it is different from other networks.
Like we have some important attributes to the minutes, like path optimality, we should have the optimal path because it's always dynamically changing situation.
Yes.
So if we consider the path optimality, as well as suppose if we consider the other parameter like loop free operation. These are the very important problems.
Yes.
So how you will take the best protocol out of all these? You have not covered AODV actually in this. AODV protocol.
Yes, sir. So in that diagnostic has already been done.
So about these two parameters, if you rate the best amongst your protocols, and why?
So that protocol I have not covered in this.
I'm
I'm just
asking the two
covering out of
parameters,
these.
the path optimality as well as the other parameter, the loop-free operation.
Yes.
So which is the best amongst your protocols you have covered in today's level?
So from today, from the Luffy, I think DS are from these protocols.
Justify it. Justify it. And one more thing that you should have some application in mind, then only you
Yes,
can
sir.
have a better
I
focus.
will.
Next paper after presentation code is 093. Can we have it? Thank you.
Good afternoon to all in one present here. I am a Mandip research scholar, Gurukhashi University, Gujarat, and my subject of discussion is related to use of RFID technology in enabling movement of visually impaired people. So the agenda, the introduction of RFID on working principles of RFID, and we can use techniques, two type of techniques, RFID valid display technique and validated systems. Last one, calculating the results. RFID technology has three main components: reader, tag, and a central computer. Manage the maintain the database. Tags make the radio signals via air, and the device is called reader pick up paper. The tag consists of passing for holding the data and antenna from communication purpose with the reader. It depends upon the chip that how hold for RFID signals can travel, but it ranges several inches, 200 plus feet. Now this slide, RFID radio frequency identification technology. Uh, RFID radio frequency identification technology is another popular name for Internet of Things. It makes the radio frequency waves to transfer data between a radar, between a radar and a movable item. RFID is a fast, reliable, and moreover, it don't require for line of science. It use automatic data capture system to identify object and any other. And RFID results efficiency and increase of the system. Now this slide we can describe the three types of tags. First of all, passive tag, uh, in which their name suggests they have no internal power supply. The microchip present in the tag remain in the sleep mode until it raise of the reader. Reader sends electronic waves and this tag activate. And manipulators then use convert these waves to digital data and send the information back the reader.
And then now the active that there have been own internal power supply which is used to power the ICs within the chip and transmit the data to the reader. Such tabs have Android such can have on-board electronics such as sensors and inputs outputs ports. These tabs communicate with reader much more reliably and compared to the passive tab. And last one tab in which falls between two categories which refer to a semi-passive tabs. These tabs have batteries to power their ICs. However, if the battery receives from electronic waves that reader sends in order to drive the data present on the tab. Now we can use RFID visually impaired peoples. There are 285 million peoples that have same visually impaired worldwide. These visually functions can be classified in four tiers. First of all, normal vision. Second, moderate visually. Third, severed visually, and fourth, complete blindness. Now let's talk about the RFID helps visually impaired people in navigation. Visually impaired people face unique challenges while navigating in while public or in places which they are not familiar with. 25% visually impaired people walk through to such a location without any assistance but just in help of walking stick. The walking stick in navigating, but it often results in longer routes and wasted his time. So it just trial and error sort of method, especially in unfamiliar locations. Nowadays, system like GPS, the global positioning systems are used to find shortest and clear path between two places. GPS works in outdoors environments, but it performs delays with use in inside of buildings. GPS signals cannot penetrate with the buildings. Several technologies have proposed that works within the buildings, and such one technology is RFID, which is my topic of my research. Navigation system for visually impaired people have been verified first in one with barley display. We can use this new technique, barley display. It is almost possible to read an electronic document your hands instead of your eyes. What blind people do in the device that enables to do this is referred as barley display. Barley display is a hardware device that displays the text present on computer screen in barley. Using this device, they can navigate through their computer systems, create and edit documents on the internet. These barley displays can be easily connected to the computer via USB connection, and it mostly don't require to install any kind of drivers. These people on the left side barley display and the right of the two blind people's work on the barley display. Capture the highlighted text on the screen. The screen reader in the translate the text in barley display. Barley displays are made of metal or nylon spins. When your users Next technique used in navigator system. The primary aim of navigator system developer cheap and easy to mobile navigation system helps visually impaired people navigate to get desired location while doing easily point to point like zebra crossing like bridge. So last we have used in RFID for visually impaired people for help confident in visually impaired people make them confident in them so they can make themselves socially active and make their presence felt keeping feeling a disability aside. There are still many amendments in need to the done in this work and assistable such as and blindness can never become hurdles in life of visually impaired people.
Can you explain how this RFID is useful for these visually impaired people? How it can help RFID? What is the role of this RFID? How is applies this RFID for visually impaired technology? We are saying that it's useful for you. How it is useful? RFID. Where is it? RFID is not used.
RFID radio waves से जो वर्क करता है सर इसे it's three parts होते हैं रीडर टैग और सेंट्रल कंप्यूटर रेडियो वेव के जो
कैसे यूज किया visually impaired people के लिए?
कैसे यूज किया था सर टू टेक्निक्स यूज किया मैंने ब्रेविगेटर सिस्टम और बाले डिस्प्ले इज कनेक्टेड टू कंप्यूटर जो भी कंप्यूटर में डाटा होता है वो उसको रीड करने के लिए उसको आईज की जरूरत नहीं होती वो टच करके अपने डिस्प्ले पे वो देख लेते हैं कि क्या लिखा हुआ है
RFID कहाँ से है वो समझाओ RFID
से रेडियो वेव से थ्रू डाटा एंटर किया जाता है
You are not able to make the clarification that how RFID technology, how it has been interfaced with the visually impaired person. Where is the RFID system in this particular time?
So like this slide, Barley display technique used for visually impaired people. It is connected to via USB to a computer.
Okay, now which is the RFID? Passive, active, or hybrid? Which one is the RFID used in this case? Which type of RFID?
RFID.
There are three types of RFIDs: active, passive.
सर एक्टिव और पैसिव को टैग में इसकी RFID में जो यूज होते हैं पैसिव टैग और इसमें यूज होते हैं
Any question from the audience?
Next paper code 102. 102. Tarun Chandwal.
My name is Tarun and I'm here to present my review paper on the securities in wireless sensor network. Well, to start with my paper, I just want to start with a corollary to age that for every law there is a key. That means that wherever there is security, there will be some parameters, there will be some methods to crack that security. Recently, Google was hacked. Google server, the whole Google organization was sent into a black hole, right? So what I'm doing in my paper is that I'm reviewing some of the security threats and coming up with some of the applications that can be implemented in some of the layers and bringing to and making a system where I will review all the security threats and add some of the security managers in each and every layer. Like U Tesla will be added, the version it will be added in the transport layer. So let me just start and explain to you what my system will look like. So as we have already known that many of my former colleagues have mentioned that what is the wireless system. So I'm just going to run through the starting slides. You know what is a wireless system. It's a system. It's a system where there are some components that send the data wirelessly. Now, these components are not only with the computer systems. These are not only the mobile devices. These components can be a simple transmitter on a rooftop that is taking all the temperature readings, or a simple transmitter in the sea that is taking all the temperature and everything. Okay. There can be various types of wireless sensor available in each and every part of the environment. Now, some of the wireless sensors have the processing power, but most of the wireless systems or the sensor nodes, they don't have that much of the power securities attached to it, because they are small, they have small processing power, they have small battery packs. Alright. Like an example, I will take that some of the spy gadgets. Now there are some spy gadgets. You have specs. There is a wireless camera built in it, and it transmits the signal over 20 meters. Now the things here are that you cannot provide that much security in such a small system that already has a wireless, that already has a battery, and that too in a small portion. So for that, what we need to do is that take all the security and put it in a cryptography, so that if ever the signal is hacked, then it is some kind of cryptic message, so that it cannot be read by the intruder. So, cryptography, and there is another method, stenography. Cryptography is hiding your message or encrypting your message. But stenography is hiding your message. Cryptography is making the lock your system, changing the bits. Where stenography we hide the message. We take a medium like image, like a sound, and we hide our message. So rather than a wireless specs sending a video signal that it is capturing, what it can send is that a sound wave it is sending. However, in that sound wave, all the video is captured. So stenography works. Just as you know that as I have mentioned, that in stenography we need a medium in which we will put all our message, and then we will encrypt that medium. That medium, like let's say that I have written a message and put it in the picture, and that picture has been transmitted over to another system using the simplest technology. If ever it is captured by an intruder, then again it won't mean anything. So some of the security threats. First of the security threat is denial of the service. Now what intruders do, that they hack into the system with their advanced technologies and their systems, and they interfere with the wireless communication. If I have a system that can generate or interfere with the wireless communication, I'll put just a simple device over a rooftop, and I will block all the signals operating in that particular locality. So that kind of a service where you put a jamming signal so that communication is not possible wirelessly can be considered under the denial of service DOS pattern. Sure. So later on I'll tell you the remedy for that. There are two types of jamming, intermittent and constant jamming. Constant jamming is that you block the signal forever and no information exchange is possible. Whereas in intermittent jamming, this is a jamming that is more frustrating because, like you are downloading a book. So let me just tell you, these are some of the attacks like black hole attack, flood attack. I'll tell you that recently Google server were hacked by a better version of the black hole attack. So in my proposed system, what I have discussed is that there are various attacks, and now I have collected some of the applications that can be implemented in some of the layers to avoid those attacks. Like these applications, Snap and EU Tesla. These are the two secure building blocks for providing data confidentiality and data freshness for broadcasting authentication. So I'll just tell you that what I'm going to do is that I'm going to take each and every layer and put some of the applications that are already there and construct a full security mechanism that can handle all the security attacks that I have mentioned in my paper. So that's the main thing. Any questions?
How is stenography is useful in wireless network? How it use it?
Yes, definitely. As I have mentioned that in stenography, like there is a wireless camera, outside your room, and you don't want anybody to take your signal, be a passive user and capture all the data. Sooner or later, he will crack your code and he will be getting all your images from your camera. And if we can design a system that there is a wireless camera and it is sending the video in form of an audio signal.
But it is very difficult because the USB devices, they are not capable of handling the video streaming.
Yeah, definitely.
So if they are not capable of video streaming, then how stenography, because you require a lot of huge bandwidth, which is not possible in WS node.
Definitely, in some of the cases it might not be possible, but then again we have all our new systems coming in that right away from the hardware itself.
No, you have to increase the size of the WS node, and the size increase, that means your principle of WS network is going to be different.
Yeah, definitely. The size will increase if we take the current video stream and then we convert it into an audio stream, and then all the processing power will be required there, and then we send it.
And even also the lifetime is going to be reduced.
Yeah, the lifetime.
Even back for the audio streaming, video streaming you might convert it into audio. The length of audio will be
Definitely. I have stated here that the video might be converted into audio stream. However, the concept here behind this is that hiding a message in another form, hiding a message like let's say that I just want to send a text message that is very simple.
My question is the example of stenography on WSN is not the exact example which you have chosen.
Yeah, definitely. But it is if if ever it is implemented in form of a hardware implementation, it cannot be done theoretically. It will be implemented in form of a hardware implementation. And if ever it is done, it would be very secure. That's the point that I have just discussed right here, right?
You have talked about the black hole attack and the single hole attack in the virus system. So where it is initiated in which layer of the architecture?
Yeah, definitely. When I talk about the black hole,
Please go here the data link layer, routing protocol, the routing layer. So at which layer this attack is initiated?
well, let me just tell you what black hole is. That
Oh, that is fine. You know, SQL backend, but by one where it is initiated?
the black hole itself is initiated. Uh, I'm just little confused. However, I know the working of the black hole, how it is taking all the messages. It involves all the layer. However, to start a black hole, we just need to convince all the neighboring nodes that send all your data through me. So it is first of all to make a black
Basically,
hole.
if you know the attack mechanism, only then you can have the different, you can see mitigation of that attack.
Yeah.
If you have to work
Yeah,
on
definitely.
protocol or you have to work on the back
For mitigating that attack, there is a software U Tesla, and it provides the data freshness and data confidentiality, and it can handle the black hole attack. That's what I have used.
Okay.
Alright, we would now be taking paper presentations on the topic antenna, VLSI, digital and analog. The first paper up for presentation 072 Nancy Gupta.
A very good afternoon to all. My name is Nancy Gupta. I'm here presenting my research paper in this international conference titled as A Compact Ultra-Wideband CPW-fed Slotted Microstrip Antenna with Truncated Ground. So this is outline of my presentation. We will start with brief introduction, then we will cover the literature review, then we will discuss the proposed antenna design structure and results and discussions. Finally, we will end up this presentation with brief conclusion and references. Let's start with introduction. The incessant progress in ultra-wideband applications and systems is commendable. Since frequency band of 3.1 to 10.6 GHz has been allocated for communication by FCC in 2002, co-planar waveguide antennas have been considered as promising choice for the role of antennas in ultra-wideband systems. Basically, co-planar waveguide antenna possess many advantages, like they are very compact in size, they have low radiation losses, they have low dispersion losses, it is easy to integrate them with monolithic circuits. This is the brief literature review that I have considered. Like in 2014, the first author, that is E. Cambranian and others, proposed a trapezoidal-shaped slotted patch antenna with CPW feed to cover the ultra-wideband from 2.8 to 12 GHz. In 2013, G. Sanyal uses a defect in the ground structure along with a circular co-planar waveguide feed to provide high gain in 12 to 14 GHz. Similarly, in 2006, Archer and other authors used an optimized air gap with a reflector from the rectangular slotted CPW feed antenna to achieve the bandwidth of 120%. So these are some other literature paper that I have considered for my antenna design. This is the proposed antenna design structure. Like we can see here from the slide that there are two diagrams. The first is the top view. In the top view, the slotted structure is the path radiator, and I'm just showing it with an arrow that this is the feed line through which the signal is coupled from the transmission line to the antenna, and these both are the ground plane.
Like you can see that truncations in ground plane has been made to achieve the wide bandwidth. Moreover, two parasitic strips have been added with the slotted structure in order to increase the antenna performance. This is figure number B. This is the side view. Here we can see the height of the substrate. The substrate that we have considered is FR4 epoxy with a height of 1.6 mm. These are the geometric parameters that are considered for the antenna design. Like this antenna is possessing very compact size of 40 mm by 26.4 mm. Now we will approach towards result and discussions. Now this is the graph of the return loss. Return loss basically represents the loss due to the reflection of signal back from the feeding line to the antenna. Basically the signal reflected will tend to interfere with the desired signal in the transmission line. So normal convention is that if the return loss is less than minus 10 dB, that means more than 90% power is transmitted. Like we can see from this graph, right from 3 to 14.32 gigahertz, the return loss is continuously less than minus 10 dB. That means for the entire frequency range, we can use this antenna structure for different applications. Next plot is of group delay. Group delay basically represents the change in phase shift of the pulse with respect to the angular frequency. More will be the group delay, the more will be the distortion in the pulses. Basically, ultraviolet transmission is done in the form of short pulses. So more will be the group delay, more will be the distortion. Like here we can see from this graph that except at 8 gigahertz, almost the group delay is constant. That means pulses are transmitted with very less distortion throughout the range. Here in this graph we have seen the effect of various vertical truncations in the ground plane. Like if we review the design again, various truncations in the ground plane has been done in order to increase the bandwidth. LG1 is the length of the vertical truncation and WT1 is the horizontal truncation. So here we can see from this return loss graph that various what would be the effect of various vertical truncations and horizontal truncations on the performance of the antenna. So next graph is the effect of parasitic strip. What will be the effect if we add one parasitic strip or two parasitic strips? Like you can see from this graph, if we add two parasitic strips in the design, the return loss is minimum. That means more power will be transmitted by the antenna. So these are the graphs of radiation pattern, which is basically a graphical depiction of how much power is radiated in all the directions by the antenna. Radiation pattern, 2D radiation pattern has been considered for the azimuth angle of 0 degree and 90 degree in order to indicate the co-polarization and cross-polarization of the E-plane. Like we can see from figure A that at 4 gigahertz the red line plot, which is almost symmetrical, that means power is radiated almost equally in all the directions. Similarly at 6 gigahertz the red line plot is almost symmetrical. These are the radiation pattern at 8 gigahertz and 10 gigahertz. Similarly at 12 and 14 gigahertz. Like we can analyze from these graphs that as we approach towards the high frequencies, the pattern is more becoming directional pattern. That means more power will be radiated in some particular directions as compared to other directions. So this is the conclusion of my presentation. Basically, this paper presents a novel design for CPW-fed slotted microstrip antenna that is having ultra bandwidth of 11.29 gigahertz from 3.03 to 14.32 gigahertz. We have used FR4 epoxy material as a substrate due to its low cost of production. Also, this design is possessing some advantages like it is very simple design, compact size, it is easy to fabricate. These are the references that I have considered. Thank you.
How can you justify that your design, which you have designed microstrip antenna, how it is different than the available design?
So normally microstrip antennas are having major drawback of bandwidth. Normally they are having very narrow bandwidth, but this proposed design is having wide bandwidth of 11.29 gigahertz. That means single antenna structure can be used for several applications simultaneously. Like at 5 to 6 gigahertz bands, it can be used for wireless LAN. At 7 gigahertz bands, it can be used for radar applications. At 12 gigahertz band, it can be used for broadcast satellites. So, single antenna design can be used for various applications.
So this is the design which you have simulated, no?
Right, sir.
And if we make a practical design, how will it will be different than this simulation?
Basically fabrication is authentication that whatever design we have simulated in HFSS, that will actually work. But the limitation here is of infrastructure, like some fabrication setup is only available in IIT, Roorkee or Thapar setup, so it is not very feasible there. So I have just shown the simulation. My next work will be to fabricate the design and authenticate it.
So this is your MTech work?
No, sir, I'm pursuing my PhD. Like I submitted my synopsis, but
Here?
from PQ, sir.
Who is the guy?
Dr. Jyoti Saxena, that is head in Gary Johnson College, Virginia.
So you have mentioned the bandwidth there is 11.929 gigahertz. It is not the bandwidth here, it is a carrier frequency of level. It's a frequency. Actually, it must be that you have a UWB bandwidth from 3.1 gigahertz to 10.6 gigahertz. So how you have exceeded to that? You have taken 11.29.
The reason is I am getting the return loss less than minus 10 dB from 3 to 3 gigahertz to 14.32 gigahertz. The return loss is continuously less than minus 10 dB. That means for the entire range, power transmission will be more than 90%. So we can use the same antenna structure for 12 gigahertz also.
Basically, you cannot have the authority to cross the range which is already standardized. It's 10.6. One thing. And another thing is that the bandwidth you are saying is it's not an ultra wide bandwidth. How you can say ultra wide? How it is different from narrow band? What's the definition from your point of view?
So usually, if the bandwidth is greater than 500 megahertz, we consider that bandwidth to be broadband. And if it is greater than 2 gigahertz, we consider it to be wideband.
If it is more than the 10% of the carrier frequency.
Carrier frequency that I have considered is 4.2 gigahertz.
But your carrier, you are taking the routes and the carrier frequencies. You are saying that bandwidth of 11.29 gigahertz. It's not bandwidth. Like you said, the bandwidth of 11.29 gigahertz. It is not the bandwidth. Bandwidth is your around 500 megahertz. You basically, suppose you are transmitting at a particular frequency. Around that frequency, if it is the bandwidth is 10% and beyond, it is called ultra wide. So, how you can say 11.29 gigahertz is your bandwidth in your research?
So I have not considered that criteria. I have considered only the this return loss parameter. That is the
That
losses are less.
That is at a particular frequency. Return loss at a particular specific frequency. So then how you can decide the usable frequency range considering the return loss?
So because
From this graph only you can show me that. Like suppose the return loss not. From here you can say what is the usable bandwidth.
So the entire band is usable.
No, it's not entire bandwidth. Just suppose you have around here it is 6 point around about 6.4 gigahertz. So at this frequency, what is the usable bandwidth for a system? Which is your ultra wideband system?
You have to interpret all these interpretation is not correct.
Yeah.
Whatever literature you have considered from that only as this definition of bandwidth.
Just go through the FCC rules for the ultra wideband. FCC rules.
Correct, sir.
FCC has specified what is the range of frequency, usable range of frequency, and what return loss level. You have taken only one parameter in this case, that is return loss.
So also consider Brookfield parameter and radiation pattern also. Like in radiation pattern again is more than
Radiation pattern is fine, but you have to consider the bandwidth that you are saying. And our question is on the bandwidth. So bandwidth, you have to suppose, like we say, a bandwidth is 3 dB of the some level. You know the bandwidth, what's the definition of bandwidth?
it should be acceptable 70.7% of the maximum gain.
Yeah, that is 3 dB.
Right.
So like this you have to specify here also.
I'll take that in mind, sir.
Right?
Okay. Thank you.
Calling the next paper after presentation is code 127 for lead copy. all of you. I'm Tulenka. I'm pursuing BTech in Electronics and Communication. My presentation is based upon the comparison between the H-shaped and E-shaped microchip antenna. The contents of this presentation are introduction to antenna, microchip antenna, some antenna parameters, different designs of microchip antenna, summary of parameters, conclusion and references. Now what an antenna is. An antenna, also called as aerial, is an electrical device which is used to convert electrical power into radio waves and vice versa. An antenna is used with radio transmitter and radio receivers. There are various types of antennas, for example, slotted antenna, horn antenna, omnidirectional antenna, directional antenna, and microchip antenna. Omnidirectional antenna is that antenna which radiates in all directions, whereas directional antenna is that which radiates in a particular direction. Electromagnetic waves are such radio waves which carry signals through the air without any loss in transmission. Microchip antenna is most widely used antenna because it has various advantages, for example, compact size, lightweight, low cost, superior portability, and many other advantages. It has applications in biomedical, satellite communication radars, and aerospace, etc. However, there are also some disadvantages of microchip antenna, which are low gain and narrow bandwidth. Now, what microchip antenna is? Microchip antenna, also called as a patch antenna, is most widely used antenna type used these days. It was first developed in 1970 for popular frequency ranging from 1 GHz to 6 GHz. Its flat and compact size make it more comfortable for airborne and spacecraft applications. It has other advantages like lightweight, low cost, low profile, superior portability, ease of fabrication, planar configuration suitable for arrays. It can be easily integrated with microwave monolithic integrated circuits. With the reduction in size and with the use of high dielectric constant material, make it useful in GPRs, receivers, handsets, and other mass-produced wireless products. The design of microchip antenna is shown in figure where X is length of patch, Y is breadth of patch, T is height of patch, and H is dielectric substrate, height of dielectric substrate. For larger bandwidth, better efficiency, and radiation, thick dielectric substrate with low dielectric constant is required, which makes it bulky. On the other hand, if we design a compact microchip antenna with high dielectric constant, makes its bandwidth narrow. So a compromise between them is always there. Next, contents will be explained by Mr. Ash.
Good afternoon everyone, I am going to explain parameters which are useful in design of microchip antenna. First, width of the patch. This is shown in the formula where T is the speed of light, epsilon R is the substrate dielectric constant, F naught is a resonant frequency. Now next parameter is patch length, which is calculated by the formula given here. Epsilon EFF is effective dielectric constant, delta L length extension. Next parameter is effective dielectric constant, which is given by the formula. And epsilon REFF is the effective dielectric constant. Epsilon R is dielectric constant, H is height of substrate, and W is the width of the patch. Now, next parameter is ground length, which is given by the formula, and where length is length of the L is length of the patch, H is height of substrate above ground. And next parameter is gain, which is calculated by the formula here, where neta is efficiency, D is directivity. Now next parameter is width of the patch, where H is height of substrate above ground, W is the width of the patch. Radiation pattern. It is the graphical representation of the radiation properties of the antenna as a function of space coordinate. Directivity. It is defined as the ratio of radiation intensity of antenna in a given direction to the radiation intensity in all the directions. VSWR. It is stand for voltage standing wave ratio. It is defined as the ratio of maximum voltage to the minimum voltage. It is given by this formula. Now, there are many types of antennas in which we are going